So can you all hear me? I hope I am audible to all of you. Okay. So in the last class, I showed you some presentation, right, regarding well foundation. So we'll continue from the next part. Okay. Can you all see my screen? Can you all see my screen? Yes. Okay. So these are now construction sequences. First of all, the first stage is what? The first stage is prefabrication. That means a prefabricated structure is constructed. Then sinking and excavation. The sinking and excavation of the well is done on the basis of their self load. Okay. Then after that we have the bottom slab plug that I just discussed in the last class. There is a bottom plug. There is a bottom plug, and after that we just do the concreting above the. You just put the well cap and then do all the necessary concreting. This is how the basic steps are there. Now we'll have stability analysis of your foundations. So I'll give you a brief overview about it. Stability analysis of your well foundations. So a well foundation, which is supporting supporting a bridge spire, is subjected to vertical and horizontal forces. The various forces acting on the well are self weight of the well and the superstructure, then live loads, then water currents and buoyancy, then temperature, wind and earthquake, then braking and tracking forces, resistance of the well walls, base and skin friction. Hmm? Now, as per IRC and IS 3955, the following design procedures are, recommended. First of all, check the stability of well under working loads, assuming elastic theory. First of all, you have to check the stability of the well under what working loads. Then we'll have to find the factor of safety of the well against ultimate failure using ultimate load theory. So these are the two basic things that are required to be what considered while designing a well. Now, design of wells basically involves the following findings. Number one, depth of the well. Number two, size of the well. Number three, design and of the other components. The depth, size, and design of the other components. Okay. Now, tilt and shift. What are these tilts and shift basically? Suppose the wheel sometimes what it shifts from its original position, maybe. Or what happens? The wheel sometimes, you know, uh, causes obstruction on one side of the wheel. So the wheel sometimes what may tilt or maybe what it may shift from its original position, right? It tilt and shift from its original position. Then like there may be certain problems. Now these problems are basically the causes, okay, of those tilt and shift. Number one, non-uniform bearing capacity. The bearing capacity is not uniform. Then number two, obstruction. If obstruction is present on one side of the well, then there may be tilt and shift. Then sand blowing in the wells during sinking. So if the sand is blowing in the wells during sinking, it will cause sudden sinking of the well. Okay. Then method of sinking. The method of sinking, the material should be removed from all sides equally. Otherwise, the well may experience tilt. You know, you understood this thing because the debris or any other material that is present in the side of the well, this should be removed, or else the well may experience what tilt. Now, sudden sinking due to blasting may also cause tilting of the well. Then irregular casting of staining will cause less friction on the side leads to chances of tilting a well. Now, the staining the well. Now, if it is not casted, in a regular manner, then this will cause what? Less friction, and which will eventually lead to the tilting of the well. Huh? Sinking of caissons. Now, caisson means what? That casing, that outer casing of the well. There may be certain sinking of caissons also. Now, in order to prevent, avoid this tilt and shift, certain precautions are required to be taken. So, what are those precautions basically? The cutting edge of the caisson must be thick and sharp pointed. The external surface of the staining and caisson curve should be smooth. The grazing should be done uniformly on all sides in all pockets of caisson. The cutting edge of the caisson must be sharp and pointed. Like the caisson means what? The cutting edge means what? That edge, through which it will be driven. That should be what? Sharp and pointed. The external surface of the staining and caisson curve should be smooth. Then brazing should be done uniformly on all sides in all pockets of the caisson. Now brazing, it should be uniformly dressed. Dressed means what? The wall well where it will be like you know casted, where it will be set up. So the all the parts near the well, it should be uniform, like a level surface. That brazing, you have to use a brazier. If it is not done, then the well will be uneven, right? So that is what the reason is. Then the caisson should be symmetrically placed. The diameter d of the curve must be placed from 40 mm to 80 mm or larger more than external diameter of the staining. So these are the questions. Can anyone say me why the caisson should be symmetrically placed? Can anyone say me why the caisson should be symmetrically placed? Can anyone say me why question should be symmetrically spaced? Or I'll start calling out your names, and I'll eventually remove you all from the meeting if you are not present. Ruben Deberma. Ruben Deberma.
Yes, sir.
Can you say why it is symmetrically placed?
No, sir.
Don't know. Sohail Roshan.
No, sir.
Okay, someone gave the answer. Yeah, if someone gave the answer in the chat box. Okay, please speak up. No problem. Just unmute yourself and speak. Kafur. Yeah, Kafur is there. Good.
Yes, sir.
Hmm.
So
Speak up.
that the structure should stay in place. So that
Okay.
the structure should stay in place and to provide it from getting displayed or get apart from them, from
Okay.
the soil.
Good. Good. Yeah. Anyone else who can speak? Taraland. Taraland. Okay, I'll mark those who have not responded. Okay, they will be marked absent today. Nitoka Sohe. Nitoka Sohe. Okay. SLC, can you speak up? Just unmute and speak up. Any other points apart from what Kafur has said?
Sir, option D.
Any other point can you say apart from this?
Um, Sorry, sir, I don't know.
Huh? Can you say? What about others? What about others? Jabajit Bhomik. Jabajit Bhomik, can you say why the question should be symmetrically spaced?
No, sir. Sorry, sir.
Okay. So the reasons are those only. Like so as to what? Stability करने के लिए. The structure should be stable, right? That is why it should be symmetrically placed. I am giving an example. Now you are trying to keep a water tank in your home. If you are to place that water tank in your home, you won't be placing it in the hill, right? You'll have to search for a level surface where you can place the water tank so as to be means you know stable and all. So that is the main reason why the question is symmetrical. So now it is rectification of tilt. Now how is the tilt be rectification? Number one is what eccentric drawing. So what is eccentric drawing? Eccentric drawing means suppose you can see here there is one vertically strong caisson. So it will be attached with a hydraulic jack, and then this tilted caisson will be tried to be pulled by this hydraulic jack. Okay. Then you is eccentric loading. Now, what is eccentric loading? So, if it is like tilted in this manner, the caisson, then in a platform you will be placing what a eccentric loading by sandfill gunny bags, like those bags of cement and like the bags for which are made of jute. They are filled with sand. Then the load is given on the other side where it has tilted, and eventually it will come to shape. Then water jetting. What is this water jetting thing? Can anyone say what is this water jetting thing? Can anyone say what is this water jetting thing?
Sir, maybe to loosen the soil.
Uh-huh. You are almost
To
correct.
loosen the soil,
Okay, to loosen the soil. Okay, okay,
so that it
Ah.
can tilt back to its positions.
okay. Good. What about others? What about others? If you don't want to me to call out your names, someone unmute and speak. If you don't want me to call out your name, someone unmute and speak. Someone unmute and speak. Apart from Ruben, if you don't want me to call out names.
Hello, sir.
Yeah, I'm hearing.
So the water supply is faced to the side of the caisson to make the tilt from the prevention of tilt to make it from the same place.
Okay, okay, good. So basically, what the water is supplied through a jet, and then what happens is that this part, the bottom part will get what dug up, right? That means this will eventually sink down. Next is what excavation on the higher side. Now this is a simple thing. Everyone knows it. If you are excavating it here using an excavator, then this will what? This will sink down, no? These are certain simple techniques. Now this is the eccentric loading only, but this is a bit more complicated. We have to put some temporary you know obstacles below this cutting edge, and then you have to place some loadings. But then this part, putting an obstacle in the bottom part, this is a very difficult task. Okay? Then pulling the wheel or caisson. Now look, this wheel or caisson can be pulled up, but this also requires a lot of time and energy, and resources are also required, heavy machinery and all. You have to like first of all, you know, put wooden slippers, and then you have to tie it with a steel rope. Then it is being pulled with a rope. So this is a very difficult task also. The initial ones are very simple. And this wooden strut thing is what? This is the permanent structure that is attached to it. Now, what will happen? This will prevent more tilting. So this will prevent more tilting. This means what? It can be pulled from this side and then again it can be made straight. Okay. There are certain like Cashian diseases. They're not important. Walking design like how the workmen are affected by this. So basically, we are almost done with this well foundation part. Okay. The video that I showed you in the last class, was it clear for all of you, or should I show you again that video? The video that I showed you in the last class, was it clear for everyone, or should I show it to you again? Yeah. Again. Okay. Fine. Now you will understand it much better. Okay, I'll show it again. Can you see the screen? Can you all see the screen? Yes? Okay, that's great.
With the passage of time, Allahabad has seen substantial increase in vehicular traffic. The old bridge over River Yamuna is a dual road-cum-rail bridge. Built in the mid-20s of the last century, this bridge is proving to be inadequate to the current traffic demands. Today, frequent traffic jams have become a regular feature of the city. To overcome this, the National Highways Authority of India, NHAI, decided to construct a new cable-stayed bridge parallel to the existing bridge under financial assistance from the Japan Bank for International Cooperation. The execution was entrusted to the Hyundai HCC joint venture. The supervision is being done by Covispan JV. Following a detailed survey of the area on both banks of the Yamuna, the National Highway Authority of India finalized alignment of the new bridge connecting GT Road on NH2 on the Allahabad side with Rewa Road on NH27 on the Naini side. The total length of the connection is 5.155 kilometers, comprising of 3.5 kilometers of approaches and 1.5 kilometers of actual bridge. The river Yamuna is still extensively used for navigational purposes by local people. Hence, another challenge before NHAI was not to disturb the navigational use of the river. NHAI, therefore, decided to opt for a cable-stayed bridge, as it provides wider navigational passage. For speedy and systematic completion of the work, The entire scope of the work was divided into 4 independent modules. Module 1 contains cable stayed portion of 630 meters length with central span of 260 meters, supported on double D well foundations with depth up to 40 meters. The approach viaduct of 515 meters length on the Naini side with spans of 60 meters founded on circular well foundations is included in Module 2, whereas the 365 meter long approach on the Allahabad side with 25 meter spans supported on 1.2 meter diameter piles is included in Module 3. Approach road works, which includes embankment works, retaining walls, cross drainage works, pavement works, safety signboards, etc., are included in Module 4. After the center line of the bridge was established with the help of precise survey, foundation works were taken up. Foundations of the pylons P17 and P18 supporting cable stayed portion had to be built in the middle of the riverbed, which were enclosed by coffer dams, access to which was provided by jetties constructed on both banks. The jetty on the Naini side is 260 meters long with double sheet pile enclosure driven by vibro sinkers. The jetty on the Allahabad side is a timber structure 100 meter long. Well foundations. The well foundation work is executed in the following stages: cutting edge, well curve, staining, bottom plug, and well cap. Cutting edge. The cutting edge serves to cut through the soil strata and facilitates the sinking of the well to the desired founding level. The cutting edge consists of back-to-back angles welded with a 12 millimeter plate bent to shape on the outer periphery. Before the final assembly of the angles, holes are drilled into the face of the angle to receive the bond bars. The cutting edge is placed on timber sleepers after the ground is leveled and center point is established. Well curve. On the cutting edge, well curve is cast in concrete within tightly fitting inner and outer forms with embedded reinforcement. Plywood formwork of PERI make is used for pylon wells. The concreting is carried out in layers using concrete pumps and transit mixers. Needle vibrators are used for compacting the concrete. The well curb is pitched into the ground by removal of sleepers placed beneath the cutting edge. The dredging inside the well curb is carried out manually. Well staining. When the well curb is partially sunk into the ground, well staining is built in lifts of 2.5 meters and sunk into the ground. Well staining for pylon wells is built in lifts of 2 meters height. The concrete is transported from the batch plant and is poured using concrete pump. For P17 well, the concrete is placed by crane and bucket arrangement. Concreting is done in clockwise direction in layers. The green concrete is vibrated using needle vibrators. Well sinking. Well sinking is an important activity and is carried out with utmost care. The wells normally sink into the ground by their own weight. The soil underneath the cutting edge and in the central dredge hole is removed by using grabs. Continuous grabbing operation is carried out till the well is sunk down to the desired level. In the case of hard strata, chiseling and grabbing method is deployed to loosen the strata, and muck is grabbed out from inside the dredge hole. Care is taken to carry out grabbing in a uniform manner inside the dredge hole. In the case of double wells, the grabbing is carried out uniformly in the outer dredge holes, employing 2 cranes, followed by the inner dredge hole. Readings are taken during sinking on the gauge marks to measure any shifts or tilts, which, if noticed, are corrected by eccentric dredging or by placing eccentric Kent ledge loads and carefully monitoring the movement of the wells. Well plug. When the well reaches the founding level, grabbing operations are discontinued and the well is made ready for plugging. Confirmatory bores are taken to study the soil parameters. Concreting of bottom plug is carried out by tremie arrangement. The tremie pipe with tightly sealed joints is lowered into the well, and a hopper is placed on top to receive concrete. A swivel concrete distributor connected to the concrete pump is placed at the center of the well. The concreting is carried out in clockwise direction, moving from one hopper to the other. Pile foundation. Module 3 of the project, namely approach viaduct on the Allahabad side, is founded on 1,200 mm diameter concrete piles. Each pile group consists of 4 piles with a total of 130 piles for the viaduct. The board cast in situ piles are installed using Casa Grande piling equipment using retrievable casing pipes. The oscillator of the piling machine is placed at the pile coordinates previously marked on the ground. Casing pipes are driven into the ground by rotating the oscillator. Verticality of the casing is checked at regular intervals. As the casing pipes are driven, a tiny grab is employed to remove the muck from inside the casing. When the casing pipes are driven to desired depth, soundings are taken to check whether further boring operation is required. Thereafter, the reinforcement cage is lowered into the bore. Concrete is placed inside the casing by crane and bucket arrangement through a tremie pipe of 200 mm diameter fitted with a hopper. Concrete is delivered continuously to the bottom of the pile bore in stages of 3 meters. When each stage is completed, the casing, along with tremie, is lifted out and concreting is continued up to about 1 meter above the cutoff level. The pile is then chipped off up to the cutoff level, and integrity test is carried out to check the soundness of pile concrete. Load testing. The installed piles are tested for the working load capacity envisaged in the design. Tests include 2 initial and routine load tests each. The initial load test consists of vertical as well as lateral loading. The vertical load is applied by a Kent ledge in the form of jumbo sandbags, each weighing 1 ton, in 9 tiers corresponding to a total load of 850 tons placed on a platform erected on top of the pile. Increments of 20% of the test load are maintained for 1 hour, and the displacement of the pile is recorded by means of dial gauges. When the final load increment is given, the final displacement is noted, and working load is calculated from load displacement graph. Pile caps. Before commencing the activity of pile caps, All the piles are exposed and chipped off to the cutoff level. 100 mm PCC is laid on the plan area of the pile gap and cured. Concreting is carried out using concrete pump and vibrated using needle vibrators. The top surface of the pile gap is made plain using trowels, and curing is carried out by bonding arrangements. Pier shafts. The pier shafts in Module 3 are of size 1200 mm by 2000 mm in plan, with heights varying from 2.5 meters to 7.5 meters, and are cast in single lift. The steel forms are made as per the design. When the rebar fixing is completed for the pier shaft, the form works are placed and aligned for the verticality and center line. Concreting for the pier shafts is carried out through crane and bucket arrangement, and it is vibrated through the needle vibrators. Deshuttering for the pier shaft is carried out 24 hours after concreting. The surface of the shaft is wrapped with Hessian cloth and curing is carried out.
पत्ते बना क्या हुआ था बारीक लगा लीजिएगा आप डायरेक्ट
Yes. Anything? Anything?